Hello, everybody. This is Michiel Oele from PRé Consultants. Welcome at our webinar, WorldSteel Data in SimaPro 8.5. We have a nice program today. If my slide is going there. We have a nice program with some of my colleagues, and I also would welcome Clare Broadbent of Steel Association. She will explain about the background of the data that we now finally have in SimaPro. So my name is Michiel Oele. You may call me Michael. Michiel is a very Dutch pronunciation of Michael. I'm a SimaPro product specialist. I'm at PRé Consultants for over 20 years, so I know my way around the product, and that's the reason that some people like to call me Mr. SimaPro. Also joining us from the United States is Paula Bernstein. She's one of our consultants and leads the SimaPro database development team, and she will show you the data in SimaPro. And finally, of course, Clare Broadbent. Clare is head of product sustainability at the WorldSteel Association, and the WorldSteel Association is the global association of steel producers. As such, she oversees the industry sustainability and LCA programs, and of course works with a lot of stakeholders, industry, academia, consultants, all that sort of things. She joined the WorldSteel Association in 2007. Before that, she worked in Eurofur and also in the steel industry in the UK. Welcome, Clare. Thank you for joining us today. So that was a short introduction of our people. I'll do a short introduction about PRé and SimaPro. Then we switch to Clare. She will tell about the background of the WorldSteel data and highlight some of the data issues. Then we'll switch to Paula, who'll tell about the new data in SimaPro, and then we'll have time for Q&A. I want to let you know this webinar is recorded. We'll put the recordings on our website, on the SimaPro Help Center. At the end of the webinar, we'll have time for Q&A. In the small GoToWebinar box, you'll find a section called Questions. There you can type your questions, and we'll pick out the most interesting ones and try to answer them during this session. And any questions we cannot answer, we'll try to make notes and make sure you get an answer otherwise. Should you not get an answer or have any questions after the webinar, feel free to reach out to us and send us an email to support@pre.nl. So most of you will know PRé and SimaPro, so I'll keep this introduction to PRé short. PRé is known because we put the metrics behind the sustainability. We do that for over 25 years. In 1990, Mark Goedkoop founded PRé Consultants because at that time, as an industrial designer, he realized that the place to change things was at the drawing table. At that time as well, LCA was sort of reinvented. And he thought, let's get rid of all these discussions like PVC is bad and painting is bad and all that sort of things. We need a quantitative approach. With some small subsidy from the Dutch government, he was able to develop a workshop. And they thought, well, let's develop a small software tool. And they would call it an app nowadays, but at that time things were still in DOS. So anyway, there was a small workshop, and everybody liked this small software tool, despite the fact that it was full of bugs. And in the end, 25 people were all looking at one screen because the other computers had crashed. Anyway, SimaPro developed, PRé developed, and now we're actually focusing on three main topics. Pioneering, we like to innovate with new metrics, such as the PEF and the social impact assessments. We do integration in companies, and we work on delivery of metrics. And SimaPro and of course the databases in SimaPro are part of that. And today, of course, we'll talk about the delivery of the WorldSteel data. SimaPro market-leading LCA software around since 1990. We estimate we have over 3,000 active users. We also have an active community of people in our LCA discussion list and other locations. And most of you actually heard about this webinar from the LCA discussion list, we found out. We work with 24 partners worldwide to support and sell SimaPro. So if you have questions and there is a partner in your country, also feel free to contact them. Used in more than 80 countries, and that's really nice because we get questions from literally all over the world, from South Africa to Iceland or from Chile to Russia. The question is kept for later. I'm now going to switch to Clare. Let's put up another slideshow. This one. And I'm going to give Clare keyboard and mouse. Yeah. Clare, you are in control now.
Okay, perfect, thank you. And good afternoon, everyone. Yes, I'm Clare Broadbent, Head of Product Sustainability here at the WorldSteel Association. And it's my pleasure to be speaking to you all to give you an update on the data that we have worked with PRé to make available in the SimaPro software. So first of all, I wanted to give you a brief introduction to the association that I work for, and then why we started on the LCI and LCA activities some years ago. Okay, I'm not sure the slides are changing, Michiel. Okay, so we're an association we've been around for over 40 years, and we're the Global Association of Steel Producing Companies. Basically, we represent 85% of the global steel production, and the global steel production is around 1.5 billion tons of steel produced every year. We have a good global coverage of our members throughout the world and throughout the different regions. Basically, the aim of the association is to act as the focal point for the steel industry, providing global leadership on all major strategic issues impacting the industry, but in particular focusing on the economic, environmental and social sustainability aspects of steel production, but also the use of steel in product applications. We do a lot of work on delivering benchmark analysis, trying to promote global market development opportunities for steel and to to the world at large, and to provide global world-class economic data and analysis on the steel industry and its value chain. And in addition to this, we have also our program, obviously, on LCA. We have good representation from around the world. We can see that we have either the steel producing companies who are our members, but also we have the national and regional associations, which helps us to sort of get a larger coverage of steel production around the world. In terms of our work programs, I think these are sort of very standard generic areas that we will work in through communications and safety and health and environmental topics. And the area which I'm responsible for, we call product sustainability. And this is where all our sustainability programs and the LCA program fit into our WorldSteel activities. In addition, we have some very specific programs. World Auto Steel for the automotive steel producers. We have a Steel University platform where we're enabling any external user, as well as our own members, to access an online steel university where you can learn about steel production. But we also have recently published an LCA module It's basically an LCA module for beginners to help teach our members and external people how we are applying LCA to the steel industry. We have a separate program on construction, construct steel, and in addition, we have a separate part which is focusing on stainless steel. My presentation here today is focusing really on the carbon steel products which we as WorldSteel are responsible for as an association. So why did we start work on LCA? This began in the early 1990s, where we wanted to understand the environmental performance of steel in product applications from a quantitative perspective. And as such, we completed our first LCI study back in 1995. And we were one of the first industry associations to publish global and regional LCI data. Since then, we've done a number of updates in 2000, 2010, and our most recent update, which we released in 2017, in September last year. And it's this data which we have made available within SimaPro. It's available in Gabi and SimaPro. We've also made it available through other databases. We're investigating other ones such as the United Nations Environment Programme, one called GLAD, and also in discussions with EcoInvent. We believe that it's good quality data, obviously coming from industry, so we want to make the data widely available so that people have an option to use the industry created data within their LCA studies. All the versions of the updates have been critically reviewed to be in line with the relevant ISO standards. We have developed a methodology report. So this was developed back in the 1990s, and since then it's been refined along the way through each progressive update. And for this latest update, we have separated it out into two reports. So the one on the left, the methodology report, is very much just focusing on the methodology. Again, it's been reviewed to be in line with ISO 14040 and 44. But also this time what we've done is separated out the inventory study, so the LCI study, which focuses specifically on the results of the data coming from the 2017 update. We also have it available in Chinese. Around 50% of global steel production is made in China. So it's quite key that we have good engagement with our Chinese members and with the Chinese LCA community so they can use the data as much as possible. So this we've made available there. And our reports are available publicly for download from our website. We do have, or we will have very shortly, an internal report which goes into even more detail for the data, but this is only available to those companies that participated in the data collection project. So you might be asking, well, what data have we provided and what's actually included within SimaPro now? We have published 46 data sets, and this is data sets which are cradle-to-steel factory gate LCIs for a number of different steel products. It's covering mainly steel production from 2014, depending on the company participating. Some is a little bit newer, some is a little bit older, but we're making sure that the data is within the 5-year cutoff rule that many standards are expecting. So we have data from 109 different steel production sites, and these have come from the members of WorldSteel, and these sites are based in 28 different countries, which we've listed here. So we've got quite a good global representation in terms of where the steel products are produced. If we look in a bit more detail, okay, there's a few acronyms here, which I can explain, which is available through our website. But basically, these are the 16 different steel products on the left, starting with the hot rolled coil, pickled hot rolled coil, and it sort of goes through all the different major steel product types. We have global data for each of them. Where we have enough data for it to remain confidential, from a company's perspective, obviously, if you've only got 2 sites providing data, we cannot do this. But where we've got a number of sites providing data, we can also create regional data. So we've done very well in terms of European coverage. A couple of products we couldn't update, we didn't have enough data, so we still have the old data from 2011. A pretty good contribution from Asia, and then a couple of products within Latin America. In terms of North America, there is data which is available on request, and this is older data currently, and this has been developed with our colleagues at the American Iron and Steel Institute, and they're in the process of updating so we have more up-to-date North American data. So in terms of the actual data that we have, I'm assuming a lot of you are not familiar with the steel production process, but here at the bottom you can see the different products that we're producing. So this is from plate to the coils, whether or not they're coated. We've got bars, rods and tubes, so they can be making pipes. And then we have structural shapes. So this is like I shapes or H shapes, which is quite often used in the construction sector. And then we also have rails, which are used in the railway lines. So these are the sorts of products that we're providing data for. And then in terms of the production process, if we're looking primarily at the what people will call the primary production or virgin steel or the integrated steel production route, this is where we're taking the iron ore and the coal, and we're processing that through a blast furnace into a basic oxygen furnace. We're also adding some scrap, because scrap is added to every single steel production process, and then we're making the crude steel, which is then rolled and formed into the different products. Alternatively, we have the electric arc furnace process. This uses a lot more scrap. It can use 100% scrap, but it can also be supplemented with some sort of virgin products as well. And then this is, in general, a simpler process where you're melting the scrap and the iron inputs together. But again, you then cast the steel, and then you can make any of these same products, which are shown below. So this is the coverage, really, sort of in quite a simple overview to show what we've actually included within our cradle-to-gate data for the steel products. In terms of the actual real number of processes, they're listed at the beginning in terms of the actual production process itself. But from coke making, sinter, pellet plant, blast furnace, and for each of these processes, we've listed the number of sites that have contributed. So if we're looking at a coke making plant, we've 40 sites which make coke, which is one of the intermediate products within the steel making process. And one of the real benefits we find of doing this at an association level is when you have 40 coke making plants all together, and when you're doing the data checks to ensure that your data quality is of a high enough standard, it's very easy with that number of processes to be able to spot errors in the data, to be able to spot outliers. Sometimes these errors, or what appears to be errors, can be actually correct. It's just a different way of processing that they have, or some different electricity grid mix, for example. But having this large number of sites participating really means that we can get a very high quality of data at the end. We find that as you go down to a lot less sites contributing, the variation in the data might sort of help to hide some of the errors within the data that's been provided. So it's a great benefit to be able to do this as an association. So we have a huge amount of data to be checked, and it's really all the inputs and outputs to the process. So our members, the steel producing companies, they collect the primary data from their own sites, and depending on the size of the company, it can be from one of their sites or numerous sites. And it's all the way from the very beginning, from the first process of coke making, all the way through to the the final product that they produce, which is quite often something like galvanizing or coating or tinplating. We have all raw material inputs, all emissions to air, water and land. And then in addition to that, as well as the products we're making, we also account for all co-products or byproducts, as well as their application. So a typical one here would be we produce slags, which can then be sold to the cement or concrete industry, which replaces their need for virgin raw materials to make their clinker. For this, we are using system expansion as the way of dealing with all of our co-products. And one of the outcomes of this can be, which we've had a number of questions on, is that this, because we're using system expansion, it could result in some negative values, which is coming from the avoided production of these materials that we're replacing. And this is typically within the ozone depletion potential impact category. So it's quite understandable why these negative numbers can exist. Or if we're using a full cradle to grave LCA, again, sometimes you might end up with some slightly negative numbers in there. We do this not just for the sites, but for all co-products, including our process gases. So within the steelmaking process, there's a lot of energy that's created, and we can then export those gases. Well, either they're used on site, but in a lot of cases, we export the gases to the local grid or to the local community. And again, we're using system expansion to take account of the benefits of doing that. This is definitely not a sales pitch for ThinkStep or Gabby, but it's just to say that this is the software that we have developed our data in. When we first started, we used Team, the Team software, but back in 2006, we switched over to using Gabby. So in terms of the upstream data, we're using either data from industry associations where possible, because we believe as an association ourselves, we would like to be able to use industry data. But where this is not possible or it's not available, then we use the data within the Gabby database. For things like electricity and energy, we can use the national grid mix, so we know where each of the sites is located, and then we can use the local electricity grid mix for that country. Similarly, for other energy inputs where we have quite a lot of national data for natural gas and things, and for diesel we can have the local data. Where this is not possible, then we try to use as much as possible global data, but otherwise it's then the data that is available. And then in terms of the actual modelling and the data verification, we have the model here at WorldSteel. We own the model. We do all the data checks and the verification, and we're working closely with our members as an iterative process to go backwards and forwards between them to make sure that we can get rid of any errors within the data they provided. And we've never received 100% accurate data from anyone. It's a very time-consuming process. People can provide data accidentally in kilograms instead of tons, in euros instead of tons, and just sort of overlooking data. So it's quite a labour-intensive process, but we take the time that's necessary, which could lead to sort of delays in publishing the data. But we want to make sure that we rule out as many potential issues as possible. Then in terms of what we end up with as the results, so as I mentioned, it's the cradle-to-gate LCI. Not very interesting to show you here in a presentation. It's a full list of over 1,000 flows, going back, connecting to all the upstream inputs. But we can show here, for example, the cradle-to-gate primary energy demand for, here I've just chosen 3 different products. If we're doing a full LCA, so including the end of life and specifying a certain percentage of the steel that's going to be recycled from the end of life, we can also take into account the benefit of recycling that steel. And depending on the scrap input, typically, because the benefit of recycling, we look at how much scrap will be saved will be recycled at the end of life, but we need to take into account that for all steel products that have been produced, we've used some scrap. So this is the net value, which you can see here below the line, and then we give the overall results in terms of the cradle to gate, including the end of life recycling credits and burdens. So this is one way, or one sort of impact that we can show. But we can also look at saying, okay, for the steel sections, these are that used in the construction sector, the hot rolled coil and the hot dip galvanized steel, what is actually contributing to the primary energy demand of the steel products. So we can see that hard coal is the use of hard coal is the main contributor. The difference here depends a bit on the production routes that our members are using to make the products. But it's quite clear to see, okay, coal is really the main one, followed by natural gas and then some renewables. If we're looking then at the global warming potential, which is one of the most common ones, again, I've just shown the same sort of thing. So on the right-hand side, we can see that really from the steel industry's perspective, it's sort of 90–95% of our global warming potential is coming from CO2, and a lot less coming from things like methane and other greenhouse gases. So we have the ability, by owning the model and using the model ourselves, we can go into great detail to see where we actually get the data from, where the results come from. But in terms of the data that we've provided through SimaPro, it's done on the higher level of just the cradle to gate information. So in terms of the actual LCI data, there are numerous applications that we have for the data. As I mentioned, that we, as well as the different products we have generated the LCI data for that I showed, we have also generated what we call a scrap LCI. This is used to quantify the burden of using scrap to make steel, as it's basically a raw material that we're putting into the process. And it also quantifies the benefits of recycling steel at the end of the product's life. By including this, then we believe that it's really a full life cycle assessment and enables the calculation of cradle to gate data, including end of life, so cradle to grave. Once you obviously do a study of a specific product, you need to then include the use phase and the manufacturing part within the process as well. But as we are the industry that actually recycles the steel, again, we felt it was appropriate that we can help provide the data and the methodology for how this can be included in the full LCA. The 16 products cover the majority of different product applications. Steel is, whether you see it or not, steel is pretty much everywhere, quite often hidden within buildings or coated and things, so you don't see it as real as the material. But our data is used for by many people around the world for doing their own LCA studies. Another application is how we can incorporate this into a product-specific LCA model. So we have developed a model we call Auto LCA, which is available via worldautosteel.org, and you can download this. It's an Excel-based model that we have, which is available for free, and internally we also have it as a Gabi model. But the idea here is that we can compare different vehicle designs with different materials to see the benefits of lightweighting with different materials and how that's going to affect the LCA. So obviously for this we're using our own LCI data for the different steel products that we have. The data is available free of charge, either through the softwares, but also we get a number of requests from people around the world doing LCA studies who have just been searching for data, and they can request this via our website. Obviously, if they're using one of the softwares where it's available, they can have access directly. Alternatively, we send the data either as a PDF or Excel file. Typically, the main section has been construction. sector or people doing LCA studies within the construction sector, but the data is really being used over a wide variety of different applications. So to finish then, what's coming next? Well, basically, I've mentioned that we've done 3 studies, and the 4th study published earlier or later last year, but that's since in the past more than 20 years now. So we have decided this year that we will switch to an annual data collection program. This doesn't mean that we update all our data every year. It's a huge task to do. But what we've decided is that over a 3 or 4 year period, all the sites will be updated, so that this gives the flexibility to the steel companies. They don't need to wait 5 years or more. If they've just missed the last data update, they can then participate on an annual basis. They can decide when it fits them best. So we're making it more flexible for them when they want to provide data. And if they want to provide it every 3 years, then they can, or if it's once every 5 years, to make sure that the data remains of a good age. So it also means that in terms of data verification, data checking, we're only getting in a quarter or a third of the overall sites each year. So it's helping on our end that we can speed up the process of publishing the data. So we started that this year. So our next update will be released before the end of this year. We're following the same methodology, so that can stay, but we will release a new study report to accompany the data to explain the changes, whether it's in terms of technological or geographical coverage. But it's an actual specific study report for the 2018 release. We'll also be able to update the background and upstream data for the raw materials. So within Gavi, this is done on an annual basis, so we'll be ensuring that the background data is always as up to date as possible. So we'll have all that updated, as well as around 30% of the steel production sites each year. So hopefully then this means that we have a much more efficient process and the data then remains more relevant for the user. All of our annual updates will be distributed to database vendors where it's currently available to ensure that they have the most relevant data available. And with that, I'd like to finish and thank you for your attention. My contact details are here. I've also included a couple of links to things that I've mentioned, which are available on our website, and I'd be happy to answer any questions.
Thank you, Claire. For those that have a question, please enter your question in the question box in the top or in the bottom right of your GoToWebinar box. After Paula has presented the WorldSteel data in SimaPro, we can look at those questions and try to answer most of them. Claire, I have one question for now. Over time, did you see a lot of change in the data? And don't mean the data quality, but did you see, let's say, significant improvements in the last 20 years in efficiency or electricity use or emissions? Because I never saw the data prior to the current release. I was just wondering what happened in the last 20 years.
Yeah, that's a good question, on which we get asked a lot. We don't really publish the comparison between the different data from each year, and this is for various reasons. I think in general the results haven't changed too much. Occasionally they might even go up a little bit. Part of this is because as LCA progresses, the data becomes more and more comprehensive and more things are being included. We're getting more data which is available for the upstream inputs. So we're actually increasing our coverage of the raw materials that we're using and the comprehensiveness of the LCI data that we're receiving. In addition, we're adding new sites. Occasionally some sites stop providing data, but more often we have new sites and new companies participating. If they are located in countries with a grid mix which has, for example, a higher carbon footprint than you might find in somewhere like Norway, then that's obviously again going to increase the overall results. So it's very difficult to do a like-for-like comparison between each of the different data collections. There are too many sort of factors which are coming in, which will vary the results positive and negatively.
Okay.
But for those people who have access to old data, then of course you can see the changes in data sets.
Yeah. Okay. We had a number of questions already in, so we'll keep them for later. Now I want to change to Paula Bernstein. She's located in the US and works in our database development team. So she's responsible for example converting the WorldSteel data into a SimaPro format. So I'm going to give the floor to Paula.
Great, thank you. Hi, everyone.
Hi. Please go ahead.
Yep, I am just sharing my screen. Okay. So just to start out, we get a lot of questions about the data conversion process itself, since the data was originally created in Gabby, as Claire mentioned, and it was provided to us then in Excel format. And this on the screen is just sort of a screenshot of how we got the data in Excel. And since the data is at the system level, we could convert each process by using a mapping of the individual flows. And then we just converted to CSV format using a tool that we have developed internally at PRé. So then we added the necessary documentation, and we're able to import directly into SimaPro. And so for those of you who don't know, the system level means that the data is aggregated, and you just see the individual flows, like in the screenshot here below, and you also see when I open up the process itself in SimaPro. And I'll just pull up SimaPro here. There isn't too much to show you, but this is just a project that I opened, and the data is in the Library Industry Data 2.0. Here's where you can find data from Plastics Europe and some other industry data sources. So it's a good resource there. If you look in the process tab here, you can find the whole list of processes under metals and then ferro, and you can see they're all listed here. As an example of the documentation, we don't have everything included here in SimaPro, so you can reference those reports that Claire referenced at the end of her presentation if you have additional questions. But you'll see here that there is some background information, and also we try to include, if you're having trouble deciding which steel process is right for you, there are a few comments on what are the typical applications for each one of these. If you open it up, you can see here on the input-output tab what we were saying about how they're on the system level. So one question also you may have is some of the duplicates for energy or land use processes. So you can see here, like occupation, these are all the same flow repeated. And this is because SimaPro doesn't regionalize land use or energy use. So while the original data had the specific region for each of these flows, when we translate it into SimaPro format, we map each of those items to the generalized flow that doesn't include the region. So here you can see a long list of flows. I can show you a quick calculation. It's since it's on the system level, it's may not show you that much information, but I figured I'd run a quick comparison here. And you can see the three regions, and that the global region is, you know, what you would expect, sort of in between the two. And other than that, I don't have too much else to show in SimaPro itself. Again, additional documentation is available online, which I linked to here, but it was also in Clare's part of the presentation. And I can hand it back to Michiel, and we can answer any questions you guys have for the last couple minutes.
Okay, thank you. We have quite a number of questions already in. So if you have questions, please leave them in the chat box. So I'll select a few questions. One question is, or two questions actually, from Remy Teuscher. The average scrap content in steel products. Can you tell a little bit about that? And the other question is related to that. Is it correct there is no 100% primary steel, and that scrap is always used in casting? And what is actually the technical or material point of view of using scrap rather than primary steel, if I rephrase it correctly? Perhaps you can say a few words about that, Claire?
Yeah, sure. So yes, all steel, whether it's defined as primary steel or secondary steel, whether it's made in the blast furnace or the electric arc furnace, all of it will have scrap. It doesn't go into the casting process in the primary route, but it goes into the basic oxygen furnace, so it gets melted down there. And it does have a use there, is to help reduce the temperature. There's a lot of energy and heat that's produced in the steel making process, so by adding in the scrap, it acts as a coolant, as well as acting as an iron source for the process. So typically within the primary route, you could have up to around 30% of the iron content produced from provided by the scrap. In the electric arc furnace, it can be up to 100%. In terms of what is the average scrap content in steel products, we'd say probably around, it's not something where you have one value for the overall steel industry, but if you look at the amount of scrap which goes in to make the 1.5 or 6 billion tons of steel each year, it's around a third on a global level. So some regions will have a lot more scrap going in, some will have a lot less. But it's sort of around a value of a third of all steel produced is made from scrap.
Yeah. Okay, thanks. Letitia Dalem from Belgium is asking if Portland cement was used as an avoided impact for the use of slags in concrete production.
Yes, I believe it was. I need to just double check and confirm. But I think that was the one. Originally, we used a combination of different types of cement. But I can provide the information. It's also available in the study report to say what's actually been used for the replacement.
Yeah. Few more questions. There's a question from Nadia Akhtar from Pakistan, I guess. She asked, do you have any specific data from Pakistan?
Unfortunately, no, not yet. If she has any context there, then we'd be happy to include them within the project. No. But for now, okay.
No. Let's see. Christopher Oberschelp is asking how representative your data are for the different regions. So if 50% of the production is in China, would you also have 50% of the sampled sites there?
No, unfortunately not. as I've shown for the different products and where we've got regional data for, then we have a greatest representation for Europe.
Yeah.
China, we do have steel production from China, but it's definitely nowhere near 50% of the global coverage. This is something that we're working on, and we'll hopefully have more Chinese data in the upcoming release.
Yeah. Now, there's a number of questions about your data in relation to eco-events. Some people said, did you compare your data with eco-events? You mentioned in the beginning you were discussing with them. Some people would like to have your steel model combined with one of the allocation models in eco-event, for example, the cutoff of methods. So perhaps you can elaborate a little bit on that.
Yeah, okay. So the data that we provide as the cradle-to-gate data is following the cutoff method approach. So you can just really see it'll have an open impact of steel scrap going into the process, but it'll just be the sort of cutoff approach for how the end of life is included. So that's what everybody will receive, and that's the data you have within SimaPro. But we also provide the methodology for incorporating the end of life approach as the sort of preferred approach from the industry. But by no means do we enforce this as the only method that can be used. In terms of eco-invent, we've had a number of discussions with them. We currently have an ongoing project to see what would be the impact of providing the WorldSteel data to eco-invent to make it available for eco-invent users. But obviously then there's the rules behind how the data needs to be provided. And we're looking at it, if we provided gate-to-gate data and connected to all the eco-invent upstreams and their approach, what would be the impact on our results? So that's part of the project. What we're finding is that obviously we've got different upstream databases which are being used, which will affect the overall results. There's a different scope. Capital equipment is included in eco-invent, whereas it's excluded within our study. But one of the biggest differences we're finding is how waste impacts are modelled between Gabi and eco-invent. So this is looking at how we could make those numbers sort of more relevant to each other. And we're also going to shortly be looking at doing a direct comparison of a cradle-to-gate data set coming from eco-invent and the WorldSteel data to see how it varies. And that's something which we'll be doing in the next month or so to see what that impact is. But obviously, if we make the data available through eco-invent as gate-to-gate data, then it's going to end up with very different results for the cradle-to-gate results due to the reasons I've just mentioned.
Yeah. Related to that about the results, did you ever compare whether the results in Gabi and SimaPro are comparable using different lifecycle impact assessment methods?
Yeah, that was one of the things which was quite key that was done. It was one of the aims, and it was Paula and her colleagues who was, from PRé who were doing that analysis to make sure we provided the impact assessment results that we got through Gabi. And I know I don't remember the details, but there were a couple which weren't matching. But then we found it was, I think, to do with the naming of different flows, and how they weren't connected to the impact categories in the same way. So yeah, that was part of the whole process of importing the data into SimaPro.
Yeah. There's a question from Jakub Grigil. I hope I pronounced it right. Do you have data for steel that are used in automotive areas, but specifically for the combustion engines production? So what kind of steel is actually used in the production of combustion engines, and do you have that data?
Yeah, I believe that's what we define as the engineering sort of steel there, and we use that, yes. so within the auto LCA model that we have as well.
Yeah, and related to that, in the beginning you mentioned you are collecting data for the carbon steel section.
Yeah.
Do you have plans to create data for stainless steel?
Yeah, so as part of the stainless steel, the ISSF, the International Stainless Steel Forum, they have a data collection project themselves. Right. This is being done in conjunction with EUROFA, so the European Steel Association. So we already have the European data available, and through ISSF, some global data which is available. So either you can contact myself and I can put you in touch with the right people if someone wants the stainless data.
Yeah. Some other questions related to your data. Do you have any uncertainty data for your LCIs?
Not specifically. We've sort of been collecting the data in terms of the data quality from the steel producers, but we haven't yet quantified the uncertainty. No.
No. Okay. A question from Avantika Shastri. Hi. Will your data be provided to the ELCD or the PEF from the European Commission?
Okay, so for in the past it was part of our data was part of the ELCD, yes. But that sort of moves on to the ILCD. For the PEF projects, there was we've sort of left this mainly to EUROFA, to the European colleagues there, because the format in which the PEF requires the data is quite different from what we're providing. I believe some data has been made available, but it's not, and it's based on the WorldSteel approach, but it's not the specific WorldSteel data.
Okay. Yeah, there's a lot of other questions, but yeah, I'll try to make a note and answer everybody individually. But I think it's about time to end this session. We're already a bit late. Yeah, well, Claire, thank you very much for your presentation and answering all the questions. Paula, also thank you for sharing your work in SimaPro. And I would like to thank the audience. We will send you a link to the recording and also probably the slides, so you can distribute it to whoever is interested. So for now, we'll stop, and I wish you a pleasant day. Thank you very much.